Okay, here is an example of a definite integral, which we would want to do using integration by parts. And I feel like I would identify that this needs to be done with integration by parts because there's a product of two things. Here's a polynomial, and here's a trigonometric function, and they are multiplied, and so I think by parts. This is the formula for integration by parts, but notice that this is for indefinite integrals, and what we have is a definite integral. So, for definite integrals, you have two choices that I can see. One, you either find the antiderivative all the way first before doing all of your evaluations, before using the limits of integration, or you could use this formula. So notice that we have the limits of integration on these two integrals here and here, but also there's the evaluation bar right here on the right for uv. And this way you could evaluate part of your integral before continuing to complete the integral. So here is that formula again. We'll save that off to the side. And so now I have to choose my u and my v. And I'm thinking sine of 2x, it's equally easy to take the derivative or the integral, so I'm not sure whether that should be u or dv. But this guy here, 2x minus 5, if I take the derivative once, I get 2, and so I think that's probably better. So I think that 2x minus 5 should be u. And that definitely means that du is going to be 2 times dx. And so if that is going to be u, then everything else that's left is going to be dv, sine 2x dx. And so I can take the antiderivative of that, and I get negative 1/2 cos 2x for v. And now I'm going to slot all four of those things into my formula. Now notice how I have the bar here with the pi over 6 and the pi over 3. And I have the u, and I have the v, and I have the v, and I have the du. And so that is going to mean that this bar is very important because, and I want to explain this before moving on, if this bar is not here, then this is a function and not a number. A definite integral is a number. This is literally a single number, and our job is to find out what it is. So that's why this formula is important. If you don't have this here, you can't write that equal sign. You don't have the right kind of expression. So I'm going to continue with my calculation by plugging in the pi over 3 and the pi over 6 and subtracting those two expressions. And then I'm going to rewrite this integral and simplify it a tiny bit. The two negatives cancel, and I get a 1 times cos 2x dx for my integral. And continuing, I'm going to do some algebra on the first half. I just simplify those two expressions. And then I evaluate the second integral, which can be done with a simple substitution, u equals 2x. And after completing some more algebra, you get pi over 6 minus 5/4 plus pi over 12 minus 5/4 again, plus 1/2 times radical 3 over 2 minus 1/2 times radical 3 over 2. And happily those cancel, and so I get pi quarters minus 5/2 as my final answer.